Right, today we are moving on to our topic, geometry. We are going to discuss on all the theorems involved in geometry. The first theorem, angles subtended by the same chord are equal. Right. Let's say we have our circle there and we have a chord. The angles that are subtended by this chord at the circumference are equal. We subtend an angle there. This angle, let's say it's x degrees, is equal to this angle subtended by the same chord, x degrees. We subtend another angle there, x degrees. So if we have a chord, we subtend any angle at the circumference, then that angle, this angle is equal to this angle, which is equal to this angle, which is equal to this angle, because all these are subtended by this same chord. So the angles subtended by the same chord are equal. That's our first theorem. Then the second theorem, this angle subtended at the center of a circle is twice that which is subtended at the circumference. If this is if this is x degrees, then this is 2x degrees. If this is 2x degrees, then this is 4x degrees. This angle is twice this angle. So the angle subtended at the center is twice the angle subtended at the circumference if they are subtended by the same chord. Then our theorem number 3, right? If we have a tangent, right? Let's say we have a tangent. This tangent, maybe it's AT. Tangent AT. A tangent is a line that touches the circumference of the circle. That's our tangent. If we have a tangent and a center O, any line that passes through the center to the point where the tangent touches the circumference, to this point, the angle formed there is 90 degrees. Any line that passes through the center, either it's a radius or the diameter, or it's just passing through that center to the point of contact of the circumference in the tangent, the angle formed there is 90 degrees. So this angle is 90 degrees. Then I've lost track of the number of theorems that we've done, so I think it's the fourth one. If we have a circle, right, we have a circle there, and we have center O and the diameter. Sorry, let's assume it's a straight line. We have a diameter there. The angle subtended by the diameter at the circumference is equal to 90 degrees. This angle is an angle of 90 degrees. Then another theorem, let's say we have our circle. We have a circle there, and we have a tangent. Then we have a chord, and we have an angle x degrees, an angle between a tangent, our tangent AT, sorry, it's AT. Let's say this is let's say it's P, this is Q. Let's say we have our angle x degrees, angle APQ is equal to x degrees. Remember, this is the chord and this is the tangent. The angle formed between the formed by the angle formed between Q, P and A. These two lines, the chord and the tangent. Any angle that is subtended at the circumference in the alternate segment is equal to this x degrees. So let's say we have this angle has been subtended by this chord in the alternate segment. This angle formed there, this angle which has been subtended by this chord is equal to x degrees. This angle is also x degrees. So any angle that has been subtended in by that chord in the alternate segment is equal to that angle between the chord and the tangent. So that's our theorem. Then let's say we have our circle there. Let me put up a question. Say we have a circle and the line A O D. Then we have parallel lines there. This one is parallel to this one. Then this is our point B, point C, point D, point O, point A, and we have a line from B to D. We have a line from B to C. Then we have this line B to O, and we have this line C to D. Right. Then you are asked to calculate A, the angle COD, then B, the angle BAD, then C, we have BDC, then D, we have BOC, angle BOC. We are asked to calculate those 4 angles. Right. If we are asked to calculate those 4 angles, we are given this, and also that this angle is equal to 28 degrees. This angle there is equal to 28 degrees. Right. If we look closely there, we have this quadrilateral I forgot to talk about that that concept concerning a cyclic quadrilateral. Right, a cyclic quadrilateral is a quadrilateral which has all its vertices on the circumference of a circle. It's inside the circle, and all of the vertices of that quadrilateral are on the circumference of the circle. So that cyclic quadrilateral, opposite angles of a cyclic quadrilateral add up to 180 degrees. So for that, we can first of all use the theorem. We have our diameter there. The angle subtended at the circumference by the diameter is equal to 90 degrees. So we already have our 90 degrees there. Then we also know that an angle subtended by a chord at the center is twice an angle subtended by that same chord at the circumference. So this is 28. So obviously this will become 28 multiplied by 2 to get 56 degrees. Then if we look closely there, we have this 56. This is a radius, this is a radius. So these base angles, these two base angles are equal. So we subtract 56 from 180 degrees. We subtract 56 to get 124. Then we divide that 124 by 2 to get 62. So this is 62 degrees, and this is also 62 degrees. Then if we look at this is a straight line, and we know that these parallel lines, they are going to form what we call Z angles. And also this angle is equal to this angle, which is equal to 56 degrees. And then this 56 degrees, right, if we look closely there, we have this 50 degrees, we have this 62 degrees, we have this 62 degrees, and we can find, what can we find there? We can find, there is no concept of there is a concept of Z angles there. So this angle should be equal to this angle. How can we find that? Let's look closely. Right, so we are saying if we look closely there, we have a cyclic quadrilateral. For us to find these remaining angles, we are saying opposite angles of a cyclic quadrilateral should add up to 108. These two should add up to 108. These two should add up to 108. So we are saying this 56 plus this 62 plus 62 plus this remaining part, they should add up to 108. So 56 plus 62, we get an 8 there, get 11 there. So 118. To get this, we are saying 180 minus 118. Then this becomes a 2, a 6. So this angle is a 62 degrees. So we can get, if we get this 62 degrees, We can also use this one. This is 90 degrees and this is 28 degrees, and this one is a radius, this one is a radius, so this 62 degrees is equal to this angle there. So we are saying this is a 62 degrees. This angle is 62 degrees. To get this angle, we are saying 62 plus 62 from 180. 62 plus 62, we have a triangle there. 62 plus 62 to get a 124 from 180. This is 6, this is 5, so this is 56. Then to get this part, we are saying 56 plus 56. It's 56 plus 56, 12, 112. Then 112 from 180. 112 from 180 to get 8 there. Then this becomes a 6. So this is 68 degrees. Then after getting this 68 and this 56, we can now find this part. So there are many methods to find those angles. So you can use any other theorem to get to our final answers there. So we are saying 56 plus 68, this is 14, this is 11, 12, 124 from 180 is 180 minus 124, this is 56. So this is 56. I hope I'm correct there. If we add 56 plus 28, what do we get? I want to verify there. 56 plus 28, this is 14, 7, 8, this is 84. Then 84 plus 62, we want to find this angle. So 82, 84, 56 plus 28, it's 84 plus 62 plus an angle of 62 there. This becomes a 6, this becomes a 40 from 180. This is 4, this is 34. So this is 34 degrees. So we are to find angle COD. COD, it's 56 degrees. BAD. BAD is 56 degrees. BDC. BDC. Oh, we haven't found that. So we have to find this angle. We can use this 28 plus 62 plus 62 from 180. So it's 62 plus 62 plus 28. 8, 10, 12. This is 12, 14, 15 from 180. So this is 28 degrees. So angle BDC is equal to 28 degrees. Then angle BOC is equal to 56 degrees. So that's circle geometry theorems. Thank you.